Hello, and welcome everyone to Stories in the Stars, a nature adventure that will have us looking up into the night sky. We're thrilled to have you join us today. It takes a few minutes for all the attendees to enter the webinar room. So as you are coming in, tell us in the chat where you are joining from, the city and state, and if you are an at-home learner or if you are joining us from a classroom. Before we get started, we'd like to review a few rules related to the virtual environment. Today, we are using a Zoom webinar room. In the webinar room, you do not have the option to turn on your video camera. You should only see the presenting hosts and panelists for today's program. The chat function has been set to panelists only, meaning you will only be able to view and chat with our presenters and hosts. This is for the safety and protection of all of us in the virtual learning environment. At certain points during the virtual learning session today, our presenter may ask you to type in the chat to answer questions or provide feedback. We will let you know when those designated times are. If you have any questions, you are welcome to enter them in the chat window at any time. We will do our best to answer questions, but may not be able to answer all of them. Please note that today's session is being recorded. Please be respectful of each other, our presenters, and hosts in the virtual environment. Bullying, inappropriate language, or behavior are all grounds for dismissal from the program. Now, I'll turn it over to our second host, Angela Brisson, to share more about today's program.
Hi, everyone. It's really nice to have you all here. I'm excited to share and teach with you about astronomy. This is a subject that I find fascinating, and so I'm really keen to share a little bit of what I know with all of you. This program is hosted by the North Carolina 4-H Camping Program, which is part of North Carolina Cooperative Extension and NC State University. So we have 3 camps that you should be able to see on your screen right now. Betsy Jeff Penn, just north of Greensboro, Millstone 4-H Camp down in the Sandhills, and then the Eastern 4-H Center out at the coast. And so we've been doing these nature adventure virtual learning sessions all fall semester, and will continue to do so. And we're really excited to be here with you all today. So before we get started and really dive into the content, we're going to cover current celestial events, so current things that are happening this month in the sky. We'll look at how to identify some constellations, and then we'll get into talking about myths or the stories behind different constellations. And then we'll wrap up with an activity at the end. If you haven't already, Dave's going to put a URL in the chat window that will take you to our Nature Adventures Story in the Stars website. And there are 2 things there that you can use for today's session. The first is, if you haven't already, you're going to want to download one of the Connect the Dot star constellations. So when you download this, it's just going to be a blank white sheet with black dots on it. And I don't want you to connect the dots yet. We're going to do that at the end of the session. But you do want to have a printout of one of those constellations. If you don't have a printer, that's okay. You can just grab a sheet of paper, click one of those links, and redraw the dots on your own sheet of paper, and that will work just as well. And like I said, we won't get to that until the end of the session today, so you've got plenty of time. The other resource that's posted on that page is the learning and discussion guide. So this is a worksheet that you can follow along during the session and kind of track your learning. I did change the presentation a little bit since I wrote the learning and discussion guide. So there are going to be a few things that are no longer covered in this session, but that's okay. Just cover what you can and answer what you can in the learning and discussion guide. All right, so we'll dive in. We're going to talk about current events in the night sky. And as always, there's some really cool things happening this month with the moon and then with Mars. And then there's also a meteor shower that we're going to cover really quickly. So as you all know, it's October. We have the 31st, Halloween coming up in just a couple of days this weekend. And October this year is really unique because we have two full moons in the month of October. On October 1st, we had the harvest moon. And then on October 31st, on Halloween, it's going to be another full moon in October. And this is what we call a rare blue moon. Does anybody type in the chat and tell me what a blue moon is? Do you think the moon actually turns blue? What's a blue moon? We'll let you type in the chat about that. And while you're typing those answers, I'll talk about the first full moon quickly that happened on October 1st. So the October 1st full moon is called the harvest moon. Each of the 12 or 13 full moons in a calendar year, they all have a distinct, unique name. And these names were given to the moons by the Native Americans who were indigenous to this country. And they called the full moon that was closest to the fall equinox the harvest moon. And the reason for that is the fall equinox, which happened in mid-September, I think September 21st or 22nd, is when the day portion of the day and the night portion of the day are equal in the amount of time that they happen. So the summer solstice, which happens in June, that's the longest day of the year and the shortest night. And then by the time that we get to mid-September, we've got equal amounts of day and night in a 24-hour period. And the full moon that happens the closest to that equinox is always called the harvest moon. So that was the full moon that happened on October 1st. And the Native Americans called it the harvest moon because the moon was out longer during the night than at any other time of the year, and they could actually harvest crops during that time. And so that's why they call it the harvest moon. Dave, what kind of answers do we have in the chat for blue moon? What do the kids think a blue moon is?
Great question. Thanks. A blue moon is when there are two full moons in the same month. The way the sun's rays hit the moon, I think it's a moon that looks blue, but not really. Two cup moons in a row. It's when the moon reflects off the ocean. That's another good answer. When the moon turns to a certain angle where it looks blue. It's another answer here is when there are two full moons.
Excellent. All right. So those were all really good answers and good guesses. And for those of you that said a blue moon is when there's a second full moon in a month, you are correct. So the moon does not actually turn blue. So just to be clear, I've got a blue colored moon up on the screen, but it doesn't really turn blue. This is just a graphically enhanced picture. A blue moon occurs when there is a second full moon in a month or a 13th full moon of a calendar year. And the reason why this happens is because on average, a full moon occurs about 12.4 times per year. And because of that 0.4, what that means is that some years you get two full moons in 1 month. And that happens about every 2.5 years. So the last blue moon that we had was in March of 2018. So this doesn't happen every year. It's relatively rare. It does happen about every 2.5 years. And that's why you hear the term sometimes once in a blue moon. And that just means that something that's unique or rare doesn't happen very often. And that's what a blue moon is. So good guesses there. All right, and then let's actually talk about what exactly is a full moon in the first place. I think I heard someone say something about sunlight reflecting, and that is 100% accurate. The moon does not produce any of its own light. It's like every other celestial body, like the Earth and our other planets and our other moons in our solar system. Other planets have moons as well. And none of these bodies produce their own light. They all reflect the light of the sun. And so that's what the moon is doing. Anytime you go outside at night and you look up at the sky and see the moon in whatever phase it's in, it's reflecting the light of the sun. A full moon happens when the Earth is placed in between the sun and the moon. So you can see in this picture here, we've got the Earth right in the middle. We've got the sun to the left, its rays coming out, and the moon on the right. And when the Earth is in between the sun and the moon like that, we can see the full face of the moon, and that's when it looks full to us and looks like a perfect, relatively perfect circle up in the sky. Now you'll notice in this diagram as well that the Earth is sitting down here a little bit below where the sun is, and the moon's up here above the Earth and the sun. Some full moons happen as what we call a lunar eclipse. And what that means is when these three bodies line up in a straight line. So if you can imagine, the Earth bumped up a couple of notches, the moon came down a couple of notches, and they're in a perfectly straight line. And then the Earth casts a shadow on the moon, and we call that a lunar eclipse. All right, so that's what's happening when we see a full moon. And again, that happens about once a month. Some months you get 2 full moons. Ours happens to be on Halloween this year, which is pretty cool. The other thing that is happening that's really neat and relatively rare right now is that the planet Mars is at opposition, or was at opposition on October 13th. So Mars is the 4th planet out from the sun. The Earth is the 3rd. And so what that means is that the Earth orbits around the sun more quickly than what Mars does. It takes Mars about twice as long to make a full orbit or a full circle around the sun. And so what happens is that as Mars is doing its thing, it's going along its orbit path, sometimes it comes closer to the Earth, and other times it's further away from the Earth. And so within a 26, 27 months or 2-year period, there's going to come a time where Mars and the Earth are as close as they are going to be to each other within the 2-year orbit cycle for Mars. And this is what we call at opposition. And so how you can see this is when you go outside at sunset, and you can go outside this afternoon and check this out for yourself. But as the sun is setting in the western sky, the planet Mars will be rising in the eastern sky. And the Earth is sitting right there directly in the middle between the two. And that's why we call it opposite, because the sun is on one side and Mars is on the other side. And we call that opposition. So Mars looks brighter and bigger in the sky than at any other time within that 2-year orbiting cycle of Mars. This is as close as it's going to be on this trip around the sun. And so you can also right now within the next few days, the next 5 or 6 days, the moon's going to be traveling around out there in the night sky, and the moon and Mars are going to come really close together. So that's another way that you can go outside at the night sky for about the next week or so and be able to find Mars. If you can find the moon, then you're going to see a really a bright red colored star next to it. And that is going to be Mars. So when we look at the night sky, Mars is one of several planets that we can see with the naked eye. And this is another opportunity for you guys to share your knowledge with me. When you're looking up at the night sky, how do you tell the difference between a planet or a star? How do you know that you're looking at a planet, or if you're just looking at a regular old star? Go ahead and type your answers, type your guesses into the chat. And Dave, if you could let me know what folks are saying as they go.
It says the right is a star and left is a planet. A planet doesn't blink. Stars twinkle, planets don't. Planets don't shine or twinkle. Stars, there are a lot more of. Planets are bright. Planets are bigger. It is not as bright. The planets are brighter and bigger. Depending on how far it is, I can tell by the size. It is brighter. Doesn't shine as much. Right is a star, because normally stars would be smaller. The sun is a star. Mars is the planet.
Yep. You guys are so right. Good answers there. So the pictures that are on the screen, the one on the left is the planet Mars, and the one on the right is a star. This is a very important star. It's our sun, which of course is the center of our solar system and what gives us daylight every single day, helps our plants grow, and makes it possible for life on Earth. So it's a really important star to us. But when we're looking up at the night sky, to tell the difference between planets or stars, you're absolutely right. Planets do not twinkle. Stars actually do twinkle, and there's two reasons that this happens. One, like we were talking about before, planets don't produce their own light. They're just reflecting light. They're not bodies of gas and energy the way that stars are. Stars put out a lot of energy in the form of heat and light, and planets aren't producing any of their own light. And because the stars are gas bodies, they've got that little bit of twinkle. So that's one reason. And the other reason that stars twinkle and planets don't is that the planets that we can see in the night sky are much closer to us than pretty much any of the stars that we can see. Those stars are much further away in physical distance. And so their light isn't as steady as what we can see from planets. And you can see planets, you can see Mercury, Venus, Mars, Saturn, and Jupiter with the naked eye out in the night sky. And actually right now, Saturn and Jupiter are hanging out in the same spot in the sky. And you can kind of tell, it's really neat. You can tell different colors for different planets. So Mars is the one that's most obvious with. You can clearly see that it's a red planet. It is a red color when you look at it. But then the other planets have different colors or different light to them as well. Venus, for example, is the third brightest body in the sky after the sun and the moon. So it's a really bright, clear light. If you look at Saturn, Saturn can actually look like a little dingy yellow brownish kind of color. So that's another way that you can make some pretty good guesses about what planets you're looking at when you look up at the night sky.
Hey, Angela, we got a good question here. Why is it red?
Why is Mars red?
I believe that it just says, why is it red?
Okay, that has to do with the composition of the rocks and minerals and sand on Mars. And I don't know specifically what the compound is within the composition of the rocks on Mars, but that has to do with why it looks red to us. So you could see something similar if you went out to the western part of the United States. There are places out west where all of the rocks are really a bright red orange. And that's similar to what's going on Mars. Great question. All right, and the other thing that's happening right now, and I don't want to spend a ton of time on it just because we only have 45 minutes for this, but there is a meteor shower that's happening, the Southern Taurids meteor shower. This is a meteor shower that happens every year from September to November, and it's peaking on October 29th and 30th. But there's not a ton of meteors or shooting stars that happen with this shower, only about 5 to 10 an hour, and they're going to be difficult to see on October 29th and 30th during peak because of the full moon, right? The moon is going to be reflecting a lot of light into the night sky, and that makes it hard to see the other stars and to see shooting stars from this meteor shower. But this meteor shower is known for producing fireballs, and these are special meteors that we call fireballs because they're bigger, they're brighter, they tend to streak longer across the sky, and that's because the rock that is producing that shooting star is big enough that it's actually going to make it to the ground. A lot of shooting stars or meteors burn up in our atmosphere, but there are ones that are bigger, and they will put off light when they're coming through the atmosphere. They'll look like a shooting star, but then they'll actually make it to the ground as well. And that's what we call a fireball, with those bigger meteors coming in. They're brighter and streak longer across the sky. Okay, so we promised that we would talk about a couple of constellations, and if we were doing an astronomy class in person together, it would be nighttime, and we would be outside, and we'd be looking up at the sky together. But because we can't do that right now, we're going to look at a couple of pictures of really easily identifiable constellations that you can go outside tonight if it's a clear night, and you can look up at the sky and see. And so the first one that we're going to talk about is Orion, the hunter. So in Greek mythology, Orion was known as a hunter. And this is a picture of him over here on the left. And the three stars that are the most iconic in this constellation are called Orion's Belt, which are these three right here, or you can see them on the right. They're the ones in the middle in this connect the dot redrawing of the constellation. And so this is supposed to be his head and shoulders. This is his middle, his legs that come out. And then over here, he has a bow where he is supposedly shooting an arrow into the constellation of Taurus, or the bull, which is over here. And so this is a really easily identifiable constellation that you can go out. If you're going out in the early evening, you're going to look to the southeast sky. And then he's going to move into the due south sky by about 9 p.m. And Orion will be in our sky all through the winter. And you can really see these three stars stand out, Orion's Belt, easily identifiable. And another thing to look for if you're trying to find Orion in the night sky is this star right up here on his left shoulder. So it's this star in the diagram and this star right here in the picture. And you can even see in the picture, the name of that star is Betelgeuse. It's a red giant star. So again, it looks red in the night sky, which is pretty cool to see the difference. Even different stars have different colors, and you can see that. And so the name of the star is Betelgeuse, and that's another way that you can confirm that you're looking at Orion. And you've got the belt in the middle, and then his left shoulder is going to be bright and red. The next constellation that we're going to look at is Cassiopeia. And in Greek mythology, Cassiopeia was a very vain queen who got stuck looking at herself in the mirror. And so you can look at the diagram here on the right. This constellation, it only has 5 stars. It's really easy to pick out. It kind of looks like a giant W up in the night sky, or depending on what time of year it is, it might look like an M. But it's only 5 stars, and it's kind of just this zigzaggy constellation up in the night sky. And so if you're looking in the southeast sky for Orion, you can turn around and look at the northeast sky for Cassiopeia. And that's another one that's really easy to find right now. All right. And we're next going to get into talking about myths, or the stories behind specific constellations, and then do some of our own storytelling at the end of this session. But before we do that, I just want to pause for a minute and see if there are any other questions that have come in through the chat, or that we can stop for a moment and answer before we get into the story portion.
Hey, Angela, you got a couple questions here about meteor showers and what causes meteor showers? Why are they bright? Why are meteors bright?
Great questions. Yeah, so meteor showers, so similar to how the Earth and Mars that we've been talking about that orbit around the sun, meteor showers are caused by asteroids or comets. And these are celestial bodies. They're much smaller than planets. And they don't really have they don't orbit in a circle. They have what we call elliptical orbits, which means it's like taking a circle and you just squeezed it on its sides and it becomes really long. And so what that means is that, sometimes we have asteroids or comets coming by, and sometimes we don't. But as those comets or asteroids are going around on their orbit, when they get close to the sun, they warm up and pieces of them start to fall off, right? They're usually made out of rocks and dust and ice. And as that comet's orbit brings it close to the sun, it'll warm up and it'll leave a trail behind it of really small pieces of space dust and space rock. And so when the orbit of the Earth comes into contact with that trail of space dust and space rock that's been left behind, that's when we have meteor showers. And those are predictable. There are certain types of meteor showers that happen at the same time every single year because the Earth is coming into contact with that comet or that asteroid trail at the same time of the year, every single year. And so those small pieces, of dust or ice or rock that have come off that comet or asteroid, they hit our atmosphere, which is a very different environment from what is out there in space. We've got oxygen and an atmosphere that's not, space doesn't have an atmosphere. And they're moving at a really fast speed. So they hit the Earth's atmosphere and they start to burn up. And that's what causes shooting stars. And there's some really great meteor showers over the summer where you can go outside and you can see as many as 100 shooting stars within an hour. So that's pretty cool. If you've never seen a shooting star, they're really neat to look at. So you can go out and try to see those right now with the torids. There's not a lot of them that are happening every hour. And then I think there was a second question, Dave. What was that second question?
There's been lots of questions since we paused here, but do zodiac signs count as a constellation?
Oh, that's a great question. So there are 88 constellations, official constellations, and all of the 12 zodiac signs are a constellation. So there's the constellation of Aries, there's the constellation of Taurus, Cancer, et cetera, et cetera. So they're related, but definitely not the same thing. But there is a constellation for each of those signs.
Another question here: if Mars is hot, then how does it have snowstorm? Is it because it gets close to the sun and then moves away, which makes it cold?
Yeah, so it's not actually hot at all. It's pretty cold on Mars. There, the atmosphere is much thinner than what it is here on Earth. And so what happens on Earth is we've got those sun's rays of light and heat that are coming to our planet. They come into our atmosphere, and then that atmosphere essentially creates this bubble around our planet that keeps the heat on here, so that we've got temperate climates. Mars, that doesn't happen. So it's actually a really cold planet, even though it's red. So you kind of think like it's red, it's warm, but it's a pretty cold planet. And so that's how it has ice, it has polar ice caps. Great question. And I'll take one more question.
Yeah, as I say, we got one more question here. What makes the sun hot?
Oh, that's a really great question. So the sun is a star, like we were talking about earlier, and there's something called nuclear fission and nuclear fusion that happens in stars, and that is a chemical process. There are many different types of chemicals, like hydrogen molecules that are in the sun, and they're all reacting with each other. And what that causes is a really big release of heat and light. And so that's the energy that the sun is producing comes out in the form of heat and light. And so that's why it's hot. And we're really positioned in a really nice place in our solar system here where it's not too hot and it's not too cold. All right. So we're going to go on to the story portion of this. So this is another chance to share your knowledge in the chat. You should see a pretty famous grouping of stars on the screen right now. Most people know what this is. So tell me what you think this is. Put it in the chat. what grouping of stars do we call this group that you can see on the screen right now? Best guess. All right, Dave, and do we have any answers, any guesses to what group of stars this is?
Yes, we've got a lot that say the little or Big Dipper.
Yep, and that is correct. This is the Big Dipper, and I bet you all think that the Big Dipper is a constellation, but it's not actually a constellation. It's a group of stars that is part of a bigger constellation. So we're going to look at this in a little bit different angle. So in that picture we were just looking at, the dipper was turned upside down. If you look here on the screen, and I apologize, this is not the best diagram, but you can see the dipper here in white. The white lines up here at the corner, this is the Big Dipper, or the group of stars that we call the Big Dipper. And that is actually part of the constellation of Ursa Major, or the Great Bear. In the Latin language, Ursa means great or big, Major means great or big, and Ursa means bear. I actually think it kind of looks a little bit like a mouse when you connect all the dots, but nobody was asking me when we named this constellation. So this is the Big Dipper is not a constellation. It's part of a larger constellation called Ursa Major, or the Great Bear. And so that's actually, there's a big distinction between constellations. There are 88 official constellations in the sky. And then asterisms, which are smaller groupings of stars that are not necessarily officially recognized all over the world. So there are only 88 constellations, but there are countless numbers of asterisms. And those are, asterisms are still, you know, a lot of people look up the night sky and see the Big Dipper and know that that is the Big Dipper, but it's not an official constellation. It's not an official grouping of stars that's recognized all over the world by scientists. And what's really neat about this is that as long as humans have been around on planet Earth, we've been looking up at the night sky and telling stories about what we find there. So if you've ever looked up at the sky outside during the day and made up stories about the clouds and shapes that you see from clouds in the sky, that's kind of the same thing, except we're doing it with stars. And what's even cooler about that is that you've got groups of people, cultures that evolved separate from each other, living on opposite sides of the planet. And they would look up at the night sky and they would pick out the same exact grouping of stars. And they might tell a different story about it. You know, to some folks, you know, the Great Bear, or Ursa Major, might actually be a mouse and have a myth about a mouse in that particular culture. But it's really cool that human beings have been looking up at the sky, telling stories, and then in cultures that are completely separate from each other, have never met, never influenced each other, they pick out the same group of stars and tell different stories, but they're still looking up at the same night sky. And that's really neat. And so we call these stories that people are telling about stars myths. And that's folklore, or stories that are really a fundamental part of a particular society or a particular culture. And the characters in these stories are often gods or supernatural humans. And so we tend to be, here in the US, most familiar with ancient Greek and ancient Roman myths. All of the names of our planets, like Mars and Venus and Mercury, all of those names come from ancient Roman mythology. And so this is something that has, you know, people have been doing this as long as there have been people looking up at the night sky and telling stories. Okay. So now we're going to look at the Pleiades, or Pleiades. I say Pleiades, but I might be putting a Southern twang on that. So you might also hear it as the Pleiades, or Seven Sisters. And this is not a constellation or an asterism. Actually, it's just a cluster of 7 stars that's part of the constellation of Taurus. And it's a really neat cluster of stars because you can look up and it's very distinct. It's very easy to see in the night sky. It kind of just looks like a dusty smudge or a dusty cloud up in the night sky. And people have been telling stories about this cluster of stars for a very long time. So what I'm going to do now is I'm going to share 2 stories, an ancient Greek story and then a story from a Native American tribe about this same cluster of stars. And so just bear with me for a moment here. Let your imaginations go. And I'm going to share 2 different stories about the same cluster of stars looking up in the night sky. So we'll start with the Greek one. And according to the ancient Greeks, the Pleiades were 7 sisters. And in Greek, the word Pleiades means doves. So the stories that the story that the Greeks told about the Pleiades is that they were the 7 daughters of the god Atlas and the ocean nymph Pleione. During an ancient war, Atlas rebelled against Zeus. Zeus was the king of the gods, and this made Zeus very, very angry. So he banished Atlas. He banished him to forever hold up the heavens on his shoulders in the night sky. And this made the sisters really sad. They weren't able to see their father anymore. And so eventually, Zeus decided to turn them into doves and let them fly away, allowing them to join their father and take their place in the night sky. And so that's the story or the myth that the ancient Greeks told about this cluster of stars. And now I'm going to share a story with you from the Onondaga tribe, which is a Native American tribe that is indigenous to New York State and the Great Lakes area. This is a little bit longer story, but again, this is about the same cluster, same 7 stars up in the night sky. And so that story goes like this. Long ago, a group of 7 Onondaga boys found a quiet place by the shores of a lake and started going there nightly for meetings. The boys wanted to do something of importance when they gathered. They wanted to be like the older men of the tribe, so they decided to do all the same traditions as the elders. They got a drum, made a fire, and started to dance, just as the elders did. Not long after they started, an old man appeared and told them to stop. He said, "You must stop this dancing. If you don't, something bad may happen." After that, the man disappeared. Some of the boys were frightened, but the oldest boy told them not to be, that it was just a trick. The boys kept meeting, but didn't dance because they were still a little afraid of what the old man had said. But after a while, the boys grew restless again. This time, they decided to have a feast. So each boy went to their parents, hoping to get some food, but their parents laughed at them and told them no. This made the boys angry. They wanted to be like the adults. So they met at their special spot and decided to dance around the fire. As they danced, their music became louder and louder. They were dancing very hard and didn't care about anything but their dance. Hearing this powerful music, the parents rushed to see what was going on. When they got to the riverside, they saw the boys dancing in a circle around the fire. But as they danced around, they were also being lifted into the sky. The parents were very frightened and called out to their boys, but the boys didn't hear them. They just kept dancing and slowly rising into the air. One mother called out to her son as loud as she could. Her son was the smallest of the boys, and she hoped she could get his attention. The young boy was the only one to hear his mother, and just as he looked towards her, he saw what was happening to him and his friends, and then they all turned into shooting stars. They all kept dancing in the sky, and that's where they still can be found today. So 2 very different takes, 2 very different stories or myths about the same cluster of stars. And that's really cool. People have been telling stories about the stars for thousands and thousands of years. And it's really cool that they're picking out the same clusters of stars and telling different stories. It's a really neat way to kind of connect us to the people that came before, to retell and relearn these stories. Okay, so I wanted to pull back up this picture of Orion. This should look familiar. You'll see the Orion constellation over here. And if you look up in the very far right upper corner of this picture, you can see the Pleiades. And they kind of look like a little dipper or just a little like smudge on the sky. If you can find Orion, you can look up to the upper right side of the sky from Orion and you can find the Pleiades. Also very easy to identify. So what we're going to do now, we're right here at the end of our time. And so we're not going to take time to do this during the presentation. But what I would like for all of you to do, if you've printed out your connect the dot star clusters, you can go ahead and connect the dots. And you're going to make up your own story about what you draw there. So look at the connect the dots, see what you think you see. Do you see a frog? Do you see a horse? Do you see a person? Whatever your imagination thinks of when you look at those connect the dots, you can connect your dots and then make up a story about what you see there. And so we're going to ask everybody to submit your stories. Have an adult, make sure that you have an adult, a parent or a guardian or a teacher who could submit this for you. And you can do it on Facebook at NC4H Camps is how it'll get to us over North Carolina 4-H or over Facebook. Or you can use the hashtag NC4H Star Stories. So you can take a video and you can post it. You can write it down on your piece of paper and take a picture of that and post it. And we're gonna, as long as you do that by 11 a.m. on Friday this week, we'll pick a few of our favorite stories that you put out there and we're gonna put them up on our Nature Adventures website. And then Friday afternoon, we will post an answer key so you can see what the official constellations are of your Connect the Dot constellation. They are real constellations. They're not any of the ones that we have looked at already today. There's one that looks similar to Orion, but it's not Orion. So you can make guesses on what those constellations are too and make up your own stories and submit them over social media to us. And we're right here at 1:45, 1:47 actually. So Dave, I'll answer one more question and then we can wrap up and see if anybody has any questions about how to submit their stories.
Sorry, I was muted there. I don't see any recent questions, but we did have Maggie said that the symbol Pleiades is the symbol for the car company Subaru, which is really neat. So if you look at the Subaru logo on those vehicles, that is Pleiades. So very, very nice.
Interesting. I didn't know that. That's really cool.
Yeah.
Well, we're really looking forward to seeing your stories. If you're doing this as a class with a teacher, maybe you all individually write a story and then pick your favorite one as a class to submit. If you're learning remotely or you're homeschool, again, make sure that you have a parent or a guardian or trusted adult who's submitting this for you. So you can tag us at NC4H Camps or submit it with the hashtag NC4H Star Stories. To take it further, there's a great book out there called Patterns in the Sky that goes through all 88 constellations and stories from many different cultures, from Asia to Europe to Native Americans and the First Nations people of Canada. So that's really neat to see all of the different stories that humans have been telling about these 88 constellations for thousands and thousands of years. You can also, I highly recommend downloading, there's the Night Sky app, which is good on both Apple products and Android products that's available for free. And that's an app that will help you identify all of the constellations. So you can just open the app, you can actually hold it up to the sky and it'll tell you what stars and what planets you're looking at. So that's a really great tool. And there are a couple of other apps out there if that one doesn't work for you. I think there's one called Star Chart, which might be a couple of dollars. It's not free, but it's also really good. So if you want to check those out and go explore the sky in your backyard this evening. All right, Dave, I'll turn it back over to you to wrap us up here.
All right. Thanks, Angela. And thanks everyone for joining us today. We had a lot of fun learning with you. Please check out Nature Adventures program schedule for the remainder of the fall semester. These programs can be attended live, or you can register for the recorded version if your schedule does not allow you to join us live. If you're interested in learning more about North Carolina 4-H or joining your local county 4-H program, please go to the URL in the chat window. Get that here. And please go to the URL, the link in the chat window for contact information for your local 4-H office. Look up your county and then the 4-H agent for the program. You can get in touch with your 4-H agent in your county and learn about how to get involved. Everyone who is attending today will receive a link to the recording of this event. We hope you will join us for the next Nature Adventures program on November 9th at 1 p.m. for Nature Crafts. We will learn about frogs, toads, and birds of North Carolina, and then build a few easy crafts with materials you can find around the house. Help us get the word out and share this with a friend if you're excited. Thank you so much again, and we hope to see you on November 9th for Nature Crafts. Goodbye, everyone.
Thanks, everybody. Have a good afternoon.